Okay, so the first section that we're going to be looking at, we're going to be looking at two different theorems. One we would have had to use if we didn't have calculators. One we've already talked about, but then we're going to add a little bit to that one as well. There's the troublemaker himself.
We should all point in the new
But I'm right here.
Oh,
No, I have to go back and I just came back to it.
oh man.
In the board.
Don't
It's like before.
I did make that mistake once where I told a kid he wasn't coming back after they sent him to the office as a joke, and he really did not come back. Okay, so like I said, two theorems we're going to go through, then we'll break and we'll do 5, 6, which is basically what we did yesterday. So it's kind of like a solidified review. Now, before I forget, tomorrow you will have a quiz on just 5.1 and 5.2. That was that first day we started this whole chapter, okay? There's a reason why I'm having y'all do a quiz on it, because I want you to start reviewing over it. Okay, so 5.1 and 5.2 quiz tomorrow, okay? Okay, so we have what's called the rational root theorem. This is the one that's in the curriculum as something you need to learn, but not necessarily use, which is silly. But after you see some of these examples worked out, you'll be thankful you don't have to use it, but you just have to learn it. Okay, so basically, I can give you any equation in the world, and you could figure out what the possible rational zeros could be. Possible. Now, I'm not saying that they are going to work, just possibly those could work. So you're going to put every number that goes into the constant over the leading coefficient, okay? All the factors of a constant over the factors of a leading coefficient. Okay, so this is if we didn't have a calculator and we had to do all of this by hand. Okay. I like to call this a pain, is what it really is. Okay. So let's look at a first example. And this is me being nice, if you will. Okay. So let's look at all the numbers that are going to go into my constant, okay? Now this is every number. So that includes both positive and negatives. So if I look at 15 and I say, well, 1, 3, 5, and 15, I'll go into 15. And I can have the positive and the negative version of that. So that's why there's plus or minuses. Okay. Thank goodness my leading coefficient is 1. Okay. Because all the numbers that go into 1 are just 1. Okay, and then I'm going to simplify that. Well, if everything's over 1, then it's just itself. So my answer is that plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. What does that even mean? That means that if we did not have a calculator to help us out, the first step in every single problem that we did yesterday, you would have to do this on top of it, okay? So this would have been the first step for every problem we did yesterday when we did synthetic division, and then we had to do quadratic formula, or we had to do factoring afterwards. This would have been the first step. And what is that first step? You would have to take all 8 of those numbers and do synthetic division to every single one of them to see which one got you a 0 as a remainder. This one's nice, okay? You're like 8 times is not nice. But that's what the rational root theorem is saying, is that these are all the ones that possibly could be a 0 for this function. So if I didn't have a calculator and I was told to find all the zeros, I would have to test all 8 of those until I got enough. At least I'd only have to find one, but my luck would be like 15, that worked. But you would only have to find one, and then from there you could do quadratic formula or factoring or whatnot after that. But that's what that root theorem is saying, is like, hey, we're going to give you a head start. This is how you can find all the possible ones. They might not work, but they're possibly going to work, okay? So what if I wasn't nice? Let's do that 36 one right there. There we go. All of the factors of the constant over all of the factors of the leading coefficient. Okay, so if we have 1, 2, and 4, and then we have 1, 2, 3, 4, 6, 9, 12, 18, and 36. Did I forget any?
Unfortunately.
Huh?
Unfortunately, there is that many.
Hello. Yeah. I do. I consider. No problem. You have your meeting right now in the auditorium. You right? Oh, when I handed them out, I didn't get you one. Okay, that's fine. They'll hunt you down. Okay, so did I forget any? Okay, so here's the ugly part. You gotta put every single one of those numerators over every single denominator. To write your final answer, that's how that's written. I told you it was a pain. I wasn't lying, okay? So if I put everything over 1, it just is what it is. Okay? Now I'm going to put everything over 2. 2 over 2 is 1. I already have that. And 4 over 2, I already have that too. You won't repeat, which is good. Okay, everything over 3. Everything over 4. So 2/4 is 1/2, and then that we've already got. Everything over 6. We've already got 1/3, and we've already got 2/3. Everything over 9. Everything over 12. We already got 1/6. We already got 1/3. Everything over 18. And everything over 36. Synthetic division 30 times. I'm with you. That's a no for me. Yeah.
Is this a problem a lot to back away from?
No, because if it was what it was supposed to be, then yes, I'd say walk away from it. But since they are only asking you to do this, then I think you're okay. Now, if they took this on top of what we did yesterday, then I would say, I'm going to take a nap.
I'll do that.
Yes.
Okay.
That's
So yeah, that is your answer for if they're asking for all of the possible rational zeros. Okay, that's a lot. Is it hard? No. Is it annoying? Absolutely. Okay. But it's just one of those that you got to know how to say, these are all the possible zeros that could work. Okay. That's the rational root theorem. Be thankful that this is all you have to do with it. Okay. All right, let's look at the next one. We have already talked about the bottom part. We've already talked about how if you have A plus BI, you also have A minus BI. We already talked about that. What we have not talked about is A plus the square root of B. You also have to have A minus the square root of B. Okay, so the conjugate root theorem says if you have both a square root or an imaginary number, you have to have the conjugate with it as well. Okay. Sure y'all heard parent night got moved to tomorrow night.
That reminds us so funny.
The test will still be on Friday. We'll finish up tomorrow. We'll review on Thursday. Test on Friday. Do not let this chapter get away from you. Okay? There's a lot in it.
There's no math. Will all the rest of these be ones that we are practicing?
I'm sorry?
Like the first one you said, like, we just have to know it. We don't have to, like, do it.
This one we've already really,
Well, yeah,
Already
but I mean, like, the rest of the
done?
ones that we're learning, are those ones that we, like, will have to put into practice?
you'll put these into practice. Okay, and if ever you need to go back and check notes, finish writing them down, I post these videos for y'all as well, okay? So, all I want for the next problems are its conjugate. Seems simple, but for some reason on the last test it got y'all. So all I want you to do is write down the conjugate. All right, so who can tell me the first one? All right, Jenna.
Or minus square root.
Okay, the next one. Okay.
5 plus the square root of 2.
5 plus the square root of 2. Okay, over here. Okay. Thank you. Yes, the only sign that changes is the sign in the middle. Leave the other one alone. Okay, what about down below? Okay. 3 minus 2i. Next one. I'm fogging up my glasses. Okay.
7 plus 8i.
7 plus 8i. Good. And our last one. Just one more. Okay.
Negative 2i.
Negative 2i. All right, so these are just the conjugates. So why do we need them? Just like we did on the last chapter. If I give you a 0 or zeros and I tell you that I want it in standard form, okay? If I want it in standard form, that means you have to multiply. If I say leave it in factored form, you get to leave it in factored form, which is nice, okay? So for the first one, I have 3 and 8i as my zeros. How do I write 3 as a factor? X minus 3, good. If I have 8i, I also have the negative 8i from before. So then I'm just going to write these as x minus 8i and x plus 8i. So if they said leave it in factored form, I would be done. But they said in standard form. So go ahead and multiply that out. Remember, do your imaginary numbers first, and then multiply it to your x minus 3. Right? Multiply your imaginary numbers first, then multiply it by your x minus 3. How long are y'all's plan of study supposed to take?
An hour.
Has anyone done theirs yet?
Yeah,
It didn't take long.
Ren, it took like
Ours was
45
really short.
minutes.
Ours took like 30.
There's
There were only like 4 kids in my academy.
Oh,
So not long, but some of them might take
I
long.
mean, it really, it's depends, because the presentation isn't very long, but then we have to like fill out our schedule for the next.
It
Gotcha.
depends on how many people are in your academy. Like,
Do what?
It depends on how many people like in your academy at the meeting. Because I only had like 4 other people in my academy.
Yeah.
I was able to leave and watch
And
it.
I had like 22, so there's still a full one, so
There were so many in my class. There were some.
most of the people were in the work.
so what do you even do with it?
You plan your study,
What?
I think
you write your schedule for the next 2 weeks, the month.
honestly. You want to switch what? I want to switch. Academy? No. Oh, no, just a class. Mine? No. Oh, yes. Dang it.
Her workload is,
This got really serious real quick.
No.
yeah, I don't want to be in your class anymore. so-
Yeah, I think I'm gonna switch it.
Hey, it wouldn't be the first or the last time someone said
I like your
that.
class, I like your class. though.
Say a lot for the people on the screen.
Oh, I got a text from Maddie yesterday.
Yeah, she
So
not,
funny. I was sitting there in third period. She was like, I do watch the videos all the way through.
unless you're not watching anymore.
Hey, Katie, sorry about your your dog is on.
Oh, that's why I had a little doctor's appointment. Sorry about your arm.
Do you want to join me and Jonah's Dave Matthews cover band?
I love Dave Matthews.
Do you want to join our cover band?
I mean, I can't play an instrument, and I can do the tambourine.
Do it.
I can do that.
And Jonah plays the drums and the guitar at the same time.
Wow.
I'm the singer.
Okay, so if I multiply by imaginary numbers, I get x squared plus 8ix minus 8ix. I don't really care how you write that because it goes away anyways. Then we get minus 64i squared. Okay, so like I said, these disappear and this becomes plus 64. Okay? So now we have x minus 3 and x squared plus 64. So you should have ended up with y equals, right? We're in the habit of writing y equals x cubed minus 3x squared plus 64x minus 192. So, huge difference between standard form and factored form, okay? If they tell you you can leave it in factored form, thank you, okay? So, for example, the next one, it says to leave it in factored form. Do that. I know some of y'all are still writing down the last problem, so I'm going to try and keep that up there as much as I can. If I give you 2 plus I, what else do you need? 2 minus I. And then we have 4 and 0. Well, if I have 0 as one of my zeros, what's an easy way to write that? Just x. And I like to write those in front anyways. So then we have x minus 4. And then we're going to write these complex numbers just like we've been writing everything else. Except it's going to look a little bit more visually unappealing than the other ones. But just x minus, we'll have 2 plus I, and x minus 2 minus I. Okay? So it's just going to have a lot of parentheses. The difference between this class and pre-cal, you'll multiply those out, okay? That's not the only difference between the two classes. That's the difference between when you learn this again.
That's not the only difference.
That's not the only difference.
Then why did I even take pre-cal?
Yeah. Pre-cal is a big step from algebra 2.
But you just need to
Huh?
This one thing.
It's just one difference.
Just one thing.
Yeah, this one difference.
Okay. Any questions on that?
In what way is it different?
Huh?
In what way is it different? Like, can you generalize?
For this?
No, like, how big of a step are you talking?
So,
Like, we talking like Golden Gate Bridge step, or are we talking like stairs to the school step?
so let me put it this way. Chapter 2. Notice how we've done quadratics in 2 different chapters, polynomials. We haven't even done rationals yet. But chapter 2 in pre-cal is all of that in one. So what used to take a chapter is now like a section. But that's chapter 2. Chapter 2, I call that algebra 2 on steroids. Because it's literally bang, 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 bang. And then it's trig from there on after logarithms. But you learn that again in here too.
Did you say trigonometry? Is that what you said?
Trigonometry
Oh boy.
is majority of pre-cal.
I'm gonna have my mom help me with that. She loved that class. That was her favorite.
I love it. Okay. Try these. Make sure you're trying both of them. Got you. Troublemaker's back. Welcome back. Okay, so for the first one, we have to multiply this one out. So we get x minus 9 and x plus 5i, but we also have an x minus 5i. Okay, So after you multiply those two together, the imaginary ones, you should have gotten x squared plus 25. And now we multiply those two together. So we end up with x cubed minus 9x squared plus 25x minus, what is 225?
Yeah.
Woo, that was good. I was thinking quarters. All right. But then the last one, all we have to worry about is writing it in factored form. And we get y equals x plus 4, which technically we're doing the same thing. We're doing x minus a negative 4, but we always know to switch it. X minus 2, we've got an x minus a 3 minus I. We have an x minus a 3 plus I. Okay. So again, I get to leave that in factored form, which is nice. Okay. Any questions on those two? Okay. Let's take our break from there and then we'll do 5, 6.